Hello, time again for another update of my works, which are continuing on the small little Darling amp. Main topic will be the heating of the amplifier and the tubes of the amplifier, and more precisely the power tubes and also the pre-tubes, which are done differently. You remember maybe last time that I mentioned that the power tubes were heated by DC, but when I tried to swap the preamplifier tubes, the drivers, to DC, it was a really big step backwards, and I reverted back to AC power for the heating of the tubes. So I thought I'd try the same also for the power tubes and go to AC heating. And for this one, or for this purpose, I purchased a separate dedicated 12.6 volt heater transformer, which is this little guy here at the bottom that you can see. And this one has got two 6.3 volt windings, and I can just really switch them in series, and I've got the ground connection as the center. And this is also how I initially used it. I used a couple of capacitors similar to the ones that you maybe see also somewhere here. So I've got a bunch of 0.1 ohm ceramic resistors, or they are in a ceramic package, but they are wire resistors, so Constantan wire resistors, and they allow to adjust the supply voltage quite precisely. So the configuration, which so far seems to be the best, is to trust AC heating for the pre-tube or driver tubes. And now there was the test of swapping to AC, and I was of course quite optimistic that also the power tubes would benefit from AC heating, but it was not the case. So the problem was not hum or anything else, but if at all, the AC heating seemed to have been, let's say, at a similar but slightly lower quality level than what I achieved with the AC heating before. So this, to my surprise, turned out to be a negative step. At first I suspected it was that due to the power supply, due to the AC, there was maybe the voltage of the heating was not really adjusted properly, but I put it all right. And you can see also still somewhere here below there are a couple of resistors. It was a different configuration when I really ran AC, but I adjusted it quite carefully, and also picked the ground and connected it to the ground of the system, so that everything saw the same ground, and I had no hum issues or anything like that. The power amplifier is dead silent, so there's nothing that doesn't come out of the speakers that you don't want to hear. But yeah, no doubt it was worse. So what I've done, you can see also, and you could have guessed already the results, because this Chinese switching power supply is back in action. And I'm also still going to use this transformer, but I'm using the heater transformer now as a choke. So here the power supply sends out a DC voltage. Nevertheless, I try to reduce all kind of artificial high frequency noise or whatever else noise comes still through the power supply, by running it through the transformer, and I use the heating wires as an input for the choke. Then it's wired through the choke itself. Then it arrives at a capacitor. This is also one of those small little Russian fellas. And I think this is a 10, what is it? I measured something like 5.5 micro farads. And then this is going to the power tubes and to the heating. And that seems to work quite well. What I've done as well is I've adjusted the voltage quite precisely. So this is a 12 volt power supply and I turn it up to the maximum, so I've got a little bit of margin. It might be even better if you go for a 15 volt, because this would allow you to reduce the voltage which is finally supplied to the tubes by some resistors. This has got the advantage that the damping of the coil and resistor and capacitor combination is increased, and you have got a bigger filter effect. That's one positive side effect if you do so. The other positive effect is that there's no short circuit through the heater wires in the tubes, so they don't really see a current peak, but the current peak is also reduced by the resistors, and the current is limited also by those resistors, so the tubes heat up relatively slowly. And I can really recognize this also when switching on the amplifier, that it takes a bit longer to finally hear some noise, or till the amplifier is finally ready for some music transmission. So this is all to the heating side. One thing when talking about the amplifier, probably you already know quite a lot about single components and so on. But when I built the amplifier, I searched for some sockets and I found this type of sockets, which I liked a lot. This is for EL34 type of tubes, and what I liked about it is first of all, it's quite a big chunky ceramic connector. It grips the tube pins very, very, very firmly, so it's almost how you say, you almost think you would destroy the tubes when you push them into the sockets. Nevertheless, then they are very, very securely fixed, and it's a very, very good contact also. And what I liked in particular is that if you have got a test setup, all of the pins with the electrical connections are also accessible from the top. So if you have got a larger hole drilled into your top plate, then you can check all of the different voltages and signals which are coming at the different pins, because here those contacts are going down to the bottom, and this is how they really look like. So you can see that the contacts are not anymore going in vertical direction, but they're in transversal direction, and they really clamp the pins. I don't know if it's probably not gonna focus properly anymore, but I hope you can see. Try to keep it at a distance that you can see also how the contacts are made, and they are really, really strong. So this is also, of course, why it's so difficult to push them into the sockets. So very, very nice, nicely done. They are not even expensive. I think I paid something like €3.50 or something for one of these connectors, and I directly bought a couple of them, and a couple of them, or two at least, disappeared into the amplifier, and I think it was really, really nice. I'm happy that I've got them. So what are the other changes that have been done in the meantime? So maybe once the camera focuses again, this is part of the power supply that you can see right now. On top there's an Elco or a big double capacitor, which is screw mounted through my epoxy plate. And the bottom, you can see the wire sticking out, or you can't really see, but they are somewhere below these capacitors. So to reduce the resistance, the internal resistance of the capacitors, I put some DC-link capacitors in parallel. These are TDK ones. I had a look at the spec sheets and they've got quite low ERS values, so they can supply loads of current. These are 1 microfarad capacitors to beef up the power supply. Still, I would like to rebuild the power supply with different capacitors and some other different things, which I'm not going to talk about here right now, but this is my future plan for the amplifier. The other changes that you can see here as well are that all of the cathode capacitors are now also paralleled by some of these Russian oil paper capacitors. And I did this for all cathode resistors because I tried just really to get rid of the cathode capacitors altogether, the decoupling caps, but the soundstage completely collapsed. It became very, very narrow, and I didn't like it at all. This was certainly not an improvement. And I reverted back first to have those very, very simple electrolytic capacitors, but then I added the oil paper ones, and this was definitely a very, very good step to do so. What I did as well was that the coupling between the driver and the end, the power tube, I upgraded by using Mondorf Evo caps. Also a good move. And last but not least, I also played around a little bit with the operation points of the driver tube, which seem to be very, very low current when directly following the build manual of the Darling amp. So I measured 3.7 milliampere of current through the pre-tubes only, which is not even on the spec sheet of the driver tube. So it's really below what normally is even measured on the spec sheet. I tried to move up the current by reducing the load resistor and also reducing the cathode resistor. I did this in several steps. Initially I had the impression it was a little bit better, but overall it lost detail. So I think it was a little bit more powerful when going towards the lower resistance and to have higher current flowing through the driver tubes, but detail seemed to have degraded and wasn't as good anymore as it used to be before. So after I've done all of the modification, I did a change back, and I absolutely definitely preferred the initial configuration where I've got a load resistor for the 8532s of 50K. And this seemed to work really, really, really well. Nevertheless, what I also did when doing all of these adaptations was to measure the grid voltage, so to really see where I am in the in the operating range of the tubes. And what I discovered with the 6J tubes as well as with the 8532 tubes was that they needed about half a volt more positive supply than what was actually listed when looking into the operating range and into the spec sheet of the tubes. So they seem to be less sensitive. This is a bit of an odd one because that is quite a lot out, considering that the operation point would be in the -1.5, -2 volt range, and having half a volt of drift to really reach the desired cathode or anode current is to me quite a big diversion from the listed specification. So what I probably do further is to really give a thorough check to the characteristics of the tubes, and then to decide what is the best operation point based on my own measurements, rather than to look at spec sheets, because they seem to be at least for this type of tube a long way out compared to what you can get nowadays. As driver tubes, I'm also still using the 6Js. I once swapped them out to the 8532, but I did not really notice much of a difference. Of course, they were not broken in. Nevertheless, I like the 6Js quite a lot, and I thought that they might be even a little bit better in combination with the other components that I've got in my system, because with the 8532s, it was going a little bit more towards the brighter, I wouldn't say harsher side, but it was a bit biased more towards the upper spectrum of the sounds. And I rather like to have something which is mid or mid-low focused to combine best with the remaining parts in my system that I've got right now. So I keep the 6J tubes for now. Nevertheless, these are also new old stock tubes, and the ones which I bought are from 1959 or 1958, so not really the newest anymore. So maybe the mil spec or the higher upgraded versions are not really so much of a difference compared to the originally old manufactured tubes. Yeah, so that's all for the amplifier right now. There's some more action going on, as I'm also working on the turntable and my turntable setup. There are also a few more components arriving soon. So what I've got built up here right now, whoops, also you can see already a bit modded, is the ERR 834 tube pre-amplifier. This one has seen also upgraded capacitors. It has got AC heating for the tubes instead of the DC heating, and again, for the low power tubes, I clearly, very clearly prefer AC heating. Right now, as the center point is not really fully tuned, I get a little bit of hum, but nothing that really hurts or is detrimental to my hearing or listening experience. But it's there's just really more life and more vivid sound when going towards the AC heating, also on those tubes. The other problem with the originally supplied circuit layout of the amplifier is that they are using conventional, maybe you can show it somewhere here, so maybe you can see here that on the circuit board it's a conventional silicon solid state rectifier, and the suggested supply voltage would be 6.3 volts for the heating. So this obviously can't really work properly, because the voltage drop on the normal silicon rectifier is too high to finally arrive at 6.3 volts for the heating of the tube. So what I measured when just really connecting the transformer to the circuit board and checking the supply voltage without any tubes, of course you're getting much too high voltages, and it's about 10 volts. But as soon as you plug in the tubes, the voltage drops to just really 5.7 volts of heating, which certainly is too low to have got enough current flow also through the small little tubes. So when I swapped back to AC heating, I just really cut whatever are the connectors, the routings of the circuit board. I just took a saw and cut them into pieces, and I then added again some resistors to arrive at, in this case, 6.2 volts of heating for the tubes altogether. The resistors are connected in such a way that I've got the wires coming from the transformers going through two of the resistors, then through all of the tubes, then through the other two resistors and back to the transformer to keep the complete circuit symmetrical. So I've got two resistors each in front of the heating wires and behind the heating wires of the tubes and connected to the transformer. This way, also similar like on the power amp, you've got a bit of a soft start, and I like this anyway, that you can go towards a higher supply voltage and then adjust the voltage to the desired level very precisely with this 1/10 of an ohm resistors. It's very easy, and you can get very precise into the voltage range that you want to, and you've got also at the same time the current limit, and I think this will be very good for the life expectation of the tubes. Yeah, so the amplifier works quite well. It's a change compared to my solid state preamp that I used for phono, but nevertheless the solid state preamp is pretty much the same thing like this one here, but with transistors. So it has got single-ended transistors, and it works in a similar way. It has got an input stage, then it has got a kind of a gain stage, which then has got the feedback with the rear how you say, filtering in the feedback loop, and you've got an output stage. And in the end it's the same thing, except that instead of the tubes you have got solid state transistors, small little signal transistors. And yeah, the sound of this one I like a lot, and I'm really waiting till the input transformers for the amplifier also arrive, which I've ordered. I've got some amorphous core input transformers to be able also to listen to MC, because my primary pickup is an MC pickup for my record player, and I'm curious to see how it all sounds and how it all combines finally together. I'm quite happy with how things are going right now, and this is all for the electronic side updates so far.